Okay, so in this question we're given an expression 2x squared plus 5x minus 10 over x minus 1 and x plus 2. And part A, we need to split it into its partial fractions, and that'll be for 4 marks. Part B, once we've done that, we will expand it up to the x squared term. So that's going to involve the binomial expansion, and it will probably involve the second year method. So let's begin part A. So the first thing we should notice is that we actually can't do the partials just yet, because the numerator has a second degree polynomial, a quadratic, and at the bottom we have a quadratic, and you can only do partials if the degree of the top of the numerator is less than the bottom. So the first thing we'll do is polynomial division. So we better expand the bottom, so I can do that just over here. So that's x squared plus x minus 2, and now we're going to do division. So let's set that up. So we have x squared plus x minus 2, and that's going to divide 2x squared plus 5x minus 10. So how many x squares fit into 2x squared? 2. And then you do 2 times this polynomial here, so we get 2x squared, then plus 2x, and then that's minus 4. And now we do subtraction, so these cancel. 5x minus 2x is 3x, and then minus 10 minus minus 4, that's minus 10 plus 4, so that's minus 6. Okay, so, and that's it, because now x squared does not fit into 3x, so we've finished, and we can write out what we've got. So we now have 2, that's this over here, plus the remainder, which is 3x minus 6 over the original thing that we divided by. And I'm just going to refactorize it, put it in that form. So that's x minus 1, x plus 2. So that's the polynomial division part. And we can see that we have a. A is now 2. And to get the b and the c, we're going to do partial fractions on this bit over here. So let's just split this up. Let's just write it. So 3x minus 6 is identical to, and it should be this bit here. We're going to make the denominator x minus 1 and x plus 2. That's this thing here. So we just look at this term, and we only have an x minus 1, so we have to multiply top and bottom by x plus 2. So that's b x plus 2 plus, and the c term, we're missing the x minus 1, so we'll times top and bottom by x minus 1. So we get cx minus 1, and we don't bother writing the denominators, we just write the numerators only. And now we can plug in some x's to get the b and the c. So the first one we'll try. Let's try x equals 1. And we're going to plug that into both sides. So on the left hand side, you get 3 minus 6 is minus 3. And that equals 3b. And this cancels, this is a 0, so therefore b equals minus 1. The next x that we're going to try is minus 2 to make this term disappear. So x equals minus 2, and on the left hand side that gives us minus 12 equals, this term disappears, and this gives us a minus 3c. So therefore c equals 4. So we now have b and c. We can now write out what we've got so far. So we have 2, and then it's minus 1. So we're going to do minus 1 over x minus 1, and then plus 4 over x plus 2. So this is part A. We've found A, B, and C. We actually have to write, I didn't actually write that A was 2, so we better write that just underneath. So A equals 2, B equals -1, C equals 4. And part B, we need to now expand this expression up to the x squared term. And we're going to obviously use the partial fraction expansion and expand these separately and then combine the answers. So part B, we better prepare this for the binomial expansion. We get 2 minus, and we're going to bring these up. So we have x minus 1 to the power of -1 plus 4 x plus 2 to the -1. And let's do some further preparations. So we want to get the number term in front, so we're just going to swap these round. So we get 2 minus, and that's -1 plus x to the power of -1 plus 4, 2 plus x to the -1. And in order to use the binomial expansion, this has to be a 1 and this 2 has to be a 1. So we're going to pull them out. So we have this equaling 2 minus, and we're going to pull the -1 out. And when you pull it out, it must come under this power of -1. So if we pull a -1 out, this becomes a 1 and that becomes a -x. It's the power of -1 plus 4. And here we're going to pull the 2 out to the power of -1. And that gives us 1 plus half x. Because if you take out a 2, you must divide both of them by 2. And lastly, just before we do the expansion, we'll just simplify this one more time. We get 2. Overall, that's a -1, so this is a plus 1. 1 minus x to the -1. And 2 to the -1 is a half, so 4 times a half is a 2. So that's 2, 1 plus half x, and there's a -1 here and a -1 there. So we're going to do the binomial expansion on each of these separately up to the x squared term. So the first one, we get a 1 plus -1 times -x, and then the third term is going to be a -1 minus 2 over 2 factorial times -x squared. And we can just simplify this. So that's 1 plus x. So this is a 2. Divide 2. 2 factorial is also 2, so that cancels, and we have a positive x squared. So plus x squared. So that's that term done. Next, we'll work on this bit. So we have a 2 in front, so I'm actually going to put that, do that at the same time and open a big bracket. And now let's expand this within the bracket. So you get 1 plus -1 half x plus -1 minus 2 over 2 factorial half x squared. Close bracket. So this equals 2. And let's just work all this out. So 1, that's plus half x. And this is a positive 2, divide 2, they cancel. And this becomes a quarter x squared. So plus a quarter x squared. And we can just expand this bracket, gives us 2 plus x plus half x squared. So now that we've expanded that term and that term, we can now combine everything. So we have a 2. So therefore the final answer is going to be 2 plus all of this. So 1 plus x squared plus all of this So plus 2 plus x. I believe this is a negative half x. So this should be a minus. So overall this is a minus x. So minus x and then plus half x squared. So the final answer we can now get is 2 plus 1 plus 2 is 5. And then x minus x, they cancel. And we have x plus half x is 3 over 2x squared. And that's the final answer.